Hey everyone, ready for a deep dive into some seriously mind-bending physics?
Always up for that.
Yeah, me too. Today we're going to be talking about black holes,
Time travel.
and even the possibility of extending human lifespans. You know,
The usual light topics.
exactly. All this came from...
Well, we were playing around with an AI chatbot
Oh, yeah.
talking about how the physics of black holes
Right.
might actually unlock some incredible technologies.
I mean, it sounds like pure science fiction, but...
It is, but some of the stuff this AI was spitting out
Yeah,
was surprisingly intriguing.
right.
Not just the usual sci-fi tropes either.
Yeah.
Some of these ideas had a real basis in, like, theoretical physics.
Okay, so before we build time machines in our garages,
Right.
let's break down some basics. I think most people have heard of black holes.
Yeah,
But understanding them is key to grasping the potential of what we're talking about today.
absolutely. So, at its core,
Yeah.
a black hole is a region of space-time where gravity is so strong that nothing,
Okay.
not even light, can escape. Well, you can picture it like a cosmic drain,
Oh, okay.
but instead of water, it's pulling in everything around it,
Right.
including time itself.
A cosmic drain. I like that.
Yeah.
So what happens when something gets sucked into this drain?
Well,
I mean, is it just gone forever?
at the very center of a black hole
Yeah.
is what's called a singularity.
Okay.
Imagine
Right.
all the matter of a star crushed into a single point, infinitely dense. Surrounding this singularity is the event horizon,
Right.
the point of no return.
Right.
Once you cross that boundary,
Yeah.
you're inevitably pulled towards the singularity.
I think I saw that in a movie once.
Probably not.
It didn't end well for the astronauts.
But what's really interesting is how time behaves
Yeah.
near a black hole. Due to this intense gravity,
Oh.
time actually slows down
Whoa.
relative to someone observing from a safe distance.
Hold on. So time slows down.
It does.
So if I were watching a spaceship fall into a black hole, what would I see?
From your perspective,
Okay.
you'd see the spaceship gradually slow down
Uh-huh.
as it approached the event horizon,
Yeah.
almost like it was stuck in slow motion.
Right.
Eventually,
Uh-huh.
it would appear to freeze completely,
Really?
just hovering at the edge.
So for the people on the spaceship,
Yeah.
time would feel normal.
Yep.
But for me, watching from afar, they'd be frozen in time.
Exactly.
That's wild.
And that's what we call time dilation.
Okay.
One of the more mind-bending consequences of Einstein's theory of relativity.
Right.
And it gets even weirder when you consider that not all black holes are created equal.
Oh.
Some of them are spinning
Okay.
at incredible speeds.
Spinning black holes, you've officially lost me.
Think about
Right.
twirling a spoon in a jar of honey.
Okay.
The honey swirls around the spoon.
Right.
Right. Well, a spinning black hole does something similar,
Right.
but instead of honey, it's dragging space-time itself
What?
along with it.
Okay.
It literally warps the fabric of the universe.
Wait, the black hole is dragging space-time.
It is.
I need a minute to process this.
It's a phenomenon called frame dragging.
Okay.
And we actually have evidence of it,
Right.
thanks to the Event Horizon Telescope,
Uh-huh.
which captured an image of a black hole a few years back.
Right.
And it confirmed that the area around the black hole was indeed swirling,
Yeah.
just as predicted by Einstein's theory.
Okay, so we've got these cosmic drains twisting up space-time itself.
Yeah.
Where does the AI chatbot's ideas fit into all of this?
Well, one of the concepts the AI proposed
Right.
was inspired by this idea of a spinning black hole warping space-time.
Yeah.
It imagined a device,
Okay.
let's call it the spinning ball,
Spinning ball.
that would mimic the conditions of a singularity by spinning at an incredibly high speed.
I'm picturing a giant hamster wheel in space.
Yeah.
But I suspect that's not quite right.
Not quite. The idea is that this spinning ball device would warp space-time around it,
Right.
just like a rotating black hole,
Okay.
potentially allowing for travel without actually moving through space in the traditional sense.
So you're saying that you could step into this spinning ball
Right.
and potentially arrive at a different location instantaneously
Uh-huh.
just by warping space-time.
That's the concept.
Okay.
But of course, there are some minor challenges.
Right.
For one,
Yeah.
the energy required to spin something that fast
Right.
and create a strong enough gravitational field
Uh-huh.
would be astronomical,
I bet.
far beyond anything we can currently generate.
That's one way to put it. What kind of material could even withstand those forces?
Exactly.
It sounds like it would rip apart anything we can build.
You're not wrong.
Okay.
We'd need materials with properties we haven't even discovered yet.
Right.
And even if we could overcome those hurdles, controlling the gravitational force is precisely enough. To safely transport something would be another massive challenge.
I can imagine.
We'd have to be careful not to accidentally create our own miniature black hole in the process.
Whoops. Okay, so maybe the spinning ball is a bit ambitious.
It might be a little bit ambitious.
For our current level of technology.
Yeah.
But what about the AI's other idea?
Okay.
I heard something about manipulating vibrations.
Right.
To travel through space-time.
Yes. That's the vibrational space-time resonance system.
Vibrational space-time resonance system.
It's based on the concept that space and time are fundamentally linked by vibration.
Okay.
We're going to need to shift gears a bit for this one.
Yeah, I think so.
Yeah.
I'm ready.
Okay.
Okay. I'm trying to wrap my head around this vibrational space-time resonance thing.
Yeah.
It sounds like something out of like a Star Trek episode.
You're not far off.
Really?
The basic idea is that every object, every particle in the universe vibrates at a certain frequency. And if we could somehow manipulate those vibrations, we might be able to tune an object to a different point in space-time, causing it to jump there instantaneously.
So instead of physically traveling through space, you'd be shifting an object's vibrational frequency to match a different location in space-time.
Exactly.
Okay.
It's like changing the channel on a radio.
Right.
You're not moving the radio itself. You're just tuning it to a different frequency.
I'm starting to see where the resonance part of the name comes in.
Right.
But is there any actual science to back this up?
Yeah.
Or is this pure speculation?
What's interesting is that we actually see hints of this concept in certain technologies.
Right.
You're probably familiar with acoustic levitation.
Oh, yeah.
Where sound waves are used to lift small objects.
Yeah.
That's a very basic example of manipulating vibrations to influence matter.
Right. I've seen videos of that. It's pretty cool.
And then there's the field of quantum computing.
Which relies on manipulating the quantum states of particles.
Right.
Which are essentially vibrations.
Okay.
At the atomic level.
So the idea of using vibrations to influence reality isn't as out there as it might seem.
It's not totally crazy.
Right.
Yeah.
Okay. I'm starting to see how this VSTR idea might have some scientific legs to stand on.
Right.
But I imagine there's still some pretty significant hurdles to overcome.
Oh, absolutely.
Like what?
For one thing, we need to develop a way to manipulate vibration with an incredible level of precision. We're talking about targeting specific points in space-time, not just randomly zapping things around the universe.
You wouldn't want to accidentally end up on the wrong side of a black hole.
Precisely.
Yeah.
And then there's the question of safety.
Okay.
We'd need to ensure that these jumps don't have unintended consequences on the object or person being transported. Yeah, you can't just start experimenting on people.
Definitely not.
But let's say for the sake of argument that we could somehow figure out how to make this VSTR thing work. What are the implications? I mean, beyond the obvious travel applications.
Well, one area that's particularly intriguing is the potential impact on human lifespans.
Oh, wow.
Remember how we talked about time dilation near a black hole?
Yeah.
Imagine if we could create a similar effect using VSTR, slowing down the aging process.
Oh, wow.
By manipulating the vibrational frequency of a person's cells.
Hold on, are we talking about actual immortality here?
Immortality is a strong word.
Okay.
But the source material does suggest that manipulating space-time could have profound effects on the aging process.
Okay.
It gets into some pretty wild ideas.
Like what? Give me the sci-fi rundown.
Well, one concept involves using finely tuned vibrations to enhance cellular repair and regeneration.
Okay.
Imagine using sound waves or targeted energy fields to repair damaged DNA.
Wow.
Or even reverse the shortening of telomeres.
Okay.
Those protective caps on our chromosomes that wear down as we age.
So it's like giving ourselves a high-tech tune-up using vibrations.
Exactly.
Okay. I can see how that could potentially slow down aging. What else?
The source material also explores the idea of manipulating gene expression using these vibrational techniques.
Okay.
We're talking about potentially switching on genes that promote longevity.
Right.
And silencing those that accelerate aging.
Wow, reprogramming our genes with vibrations.
It's a pretty wild idea.
Yeah.
It sounds incredibly complex, even if it were possible.
Right.
But think about the progress we've made in gene editing technologies, like CRISPR in recent years.
And our understanding of epigenetics,
Exactly.
the study of how environmental factors can influence gene expression is rapidly advancing.
It is.
So you're saying that while we might not be reprogramming our genes with vibrations tomorrow, the foundation for such technologies is being laid.
Exactly. The key takeaway here is that our understanding of aging is evolving from something we passively endure to something we might be able to actively manipulate.
Okay, this is getting pretty mind-blowing.
It is.
What other wild ideas did the source material throw out there? I'm ready for more sci-fi.
Well, how about this?
Okay.
Temporal stasis.
Temporal stasis.
Imagine creating a localized distortion in space-time where time essentially stops. For an individual. It's like hitting the pause button on their personal timeline, preserving them perfectly without any biological processes occurring.
So it's not cryogenics where you're freezing someone's body. You're talking about literally stopping time for them.
Precisely. It raises a fundamental question in physics. If we can manipulate time, can we completely halt its effects on a biological system?
Okay, that one is definitely going in the things to ponder late at night category. Anything else?
One last idea.
Okay.
And it's a doozy.
Okay.
Energy-based cellular sustenance.
Energy-based cellular sustenance.
The concept is that we could potentially bypass the normal processes of metabolism and aging by directly supplying cells with energy from external sources, perhaps using precisely tuned vibrational energy fields.
Wait, are you saying we could power our cells directly?
It's a very...
Like plugging them into a cosmic wall outlet?
That's a very simplified way of putting it.
Okay.
But you've got the gist. It's targeting the mitochondria.
Okay.
The powerhouses of our cells, which are known to decline in function as we age.
So it's like giving our cells a continuous energy boost to combat the wear and tear of time. I'm not sure if I should be excited or terrified by these possibilities.
Well, it's important to remember that these are all highly speculative ideas.
Okay.
The science is nascent. The technology far beyond our current capabilities.
Okay, so maybe we won't be achieving immortality anytime soon? But these concepts are definitely food for thought.
Absolutely.
Yeah.
And that's what makes this deep dive so fascinating. It pushes us to grapple with the boundaries of what might be possible.
I feel like we've covered a lot of ground here.
We have.
But I can't help but think about the bigger picture.
Okay.
What would the world look like if we could actually achieve these kinds of lifespans? The implications are pretty mind-boggling. I mean, it's almost like we need a whole new way of thinking about society if people could potentially live for centuries.
It really is.
I mean, where do you even begin to unravel the implications of that?
It's a question that raises more questions than answers. Think about the impact on population growth if people are living longer. That's a lot more mouths to feed, resources to manage.
We're already facing challenges with sustainability as it is.
Exactly.
And what about the economy?
Oh, yeah.
Would people still retire at 65? If they could potentially live for another 100 years?
It's hard to imagine.
I mean, the whole concept of work and leisure would need to be completely reevaluated.
Absolutely.
And then there are the social implications.
Oh, yeah.
Would family structures change?
Totally.
How would relationships evolve over centuries? It's a whole new paradigm to wrap our heads around.
It really is.
Almost like we need to rethink everything. About how society is structured. From education and healthcare to governance. And even the concept of death itself.
Wow.
It was a bit overwhelming to consider, honestly.
There's definitely a lot to process.
Yeah.
But even if these longevity technologies remain firmly in the realm of science fiction, the mere possibility of their existence forces us to confront some fundamental questions about what it means to be human and what kind of future we want to create.
I feel like we've only scratched the surface of this incredibly complex and fascinating topic.
It is.
We've gone from black holes to time travel to the potential for radical life extension.
Right.
It's been quite a journey.
It's a testament to the power of human curiosity.
Yeah.
And our drive to explore the unknown.
Right.
Even if we never achieve these seemingly impossible feats.
Right.
The pursuit of knowledge itself is invaluable.
So what can our listeners take away from this deep dive? What's the big picture takeaway?
I think the most important lesson is that we are living in an era of extraordinary scientific and technological advancement.
Right.
The things we've discussed today, as mind-boggling as they may seem,
they really are
grounded in real scientific principles.
Right.
Who knows what breakthroughs await us in the coming decades?
It's a reminder to stay curious.
Yeah.
Keep questioning.
Absolutely.
And never lose that sense of wonder about the universe.
Yeah.
And our place in it.
And who knows, maybe one day we'll look back on this conversation and marvel at how far we've come.
Right.
How the seemingly impossible became possible.
Well, I, for one, am excited to see what the future holds.
Me too.
Thanks for joining us on this mind-bending exploration of black holes.
Yeah, this was great.
Space-time and the quest for longevity.
Absolutely.
Until next time, keep exploring the universe and all its mysteries.